Hello again. Tonight's topic is indistinguishable from magic. And if you know Arthur C. Clarke, you'll understand what I'm referring to. Whenever you're showing off something new in a technology or scientific discipline, if you're not aware of it, you don't have understanding for it, you don't have the vocabulary foundation for it, you either just accept it as is, kind of like some aspect of AI, or you just like, well, I don't understand it, so it's kind of like magic. So you just take it as magic, in which case the people that are presenting it have the potential, don't know if they use it or not, to misrepresent what they're talking about to actually make it in their favor monetarily. And so I said, well, what are the earliest things I can think of that would be indistinguishable from magic? And it drew me back to Mel Brooks' History of the World, Part One. Moses coming out with the 15 commandments. And then he drops one of the tablets and goes, no, 10 commandments. Having seen both that and the actual movie, The 10 Commandments from back in the day, my thought is, was that a burning bush or was that a voice response computer terminal display? Is that an ethereal voice from nowhere or is that just computer speech speaker output? I don't see any person. Where's the voice coming from? Tablets. It says tablets, so everybody just assumed they're stone tablets. What if it's just a tablet computer display and it started rattling off the 10 commandments in text? Is the information source being called upon all seeing and all knowing, or is it just wireless access to a cloud service? Do they know you? Are they watching over you at all times, all seeing and all knowing, or is it just that they have a mobile device with location services or satellite observing? So we're now moving closer and closer to the point where things are going to become inexplicable magic, and hopefully the magic will be tolerated and there won't be a rebellion against the advancements of technology. So how is this sort of separation happening? Well, it turns out there's a lot of splintering and branching and compartmentalizing. Science itself isn't just one thing anymore. Science, physics, chemistry, it's branching into a number of different areas, but those are actually branching out further. For example, physics, there's particle physics, and within particle physics, there's all sorts of specific particle physics. And in physics, there's also optics. Optics are now branching out into nanoscale nonlinear optics. So you're working in tighter and tighter niches with smaller and smaller groups of people that know everything about what they're working on, but maybe don't even know about the stuff that's just beyond what they're working on. Whatever formal education you go through, you'll get some basics, the elemental stuff of physics, including the elements, but the underlying vocabulary of physics. And you'll realize that there's more down those rabbit holes than you're taught, than you have time to learn in the short formal education you have. And even if you go off to more advanced educational institutions, higher tiers of education, so to speak, even those can't cover it all. And they're going to splinter further into you won't just go to a university and learn physics. You'll be learning physics, but you'll also be specializing in optics. But even optics is now into nanoscale nonlinear optics. So you may not get what you need to know about a specific technology until you actually get out in the job market and you have an active job and you have peers that also need to understand the same stuff. So you might only know what your network knows, what the people in your little community know, and the rest of the world is oblivious to whatever you're working on and its minutia. The people that are in that area, they have to possess the ability to do rapid assimilation. So when new stuff comes out, when something is there that you don't know, you've got to rapidly learn it, understand it, become competent in it. And then you need to take that as your new foundation, connect those dots, come up with new postulations, new things you can try and fabricate. And then you've got to learn how to test it. What are the kinds of tests? You may have to create the tools to test what you're testing. My adage is you'll never know how much you didn't know until you know what you didn't know. So even those people go into a job not knowing everything about what they're working on. And then you have the timeline collapse between demonstration of something promising until it becomes a product. Large corporations don't mind spending $10 million on some bleeding edge technology that may not pan out. But if it does pan out, they can see the potential and they want to own sole ownership of that intellectual property, and they can make the tens of billions off of it. Companies will participate in this stuff for their own gain. And if it doesn't pan out, they'll shut you down and go work on something else, or they'll retask the team to go work on something new. DARPA does a lot of this stuff. They'll give a grant to something promising, and if it pans out, all of a sudden it becomes government classified. If it doesn't pan out, your grant's gone. But once it makes it where it's technological property, the next thing that happens is you'll see consortiums. There are consortiums. You'll find a bunch of companies that click together that, we'll make this aspect of it if you'll make that aspect of it, and together we'll make the product. These companies that get together, they create the consortium in order to create the product. And if you pay money, you can get access to the intellectual property. If you're on the outside, this is not public knowledge. This is something you have to pay to get the detailed information, the minutia, and you'll be left out in the cold. And if you're thinking you're going to advance when they advance, they want you to be left to wither on the vine and maybe go away and go do something else. There's a slant to this that is meant to basically create revenue streams. The initial demonstrations can come from anywhere on the planet, obviously, but increasingly, the places where this is coming from is well-funded research labs in China. And then the companies that first produce the products that maybe you go find on Amazon or on some other place, those are companies in China, because they'll get a collective of a couple of companies together to go, okay, you make this technology, we know you make this baseline product, put the two together, now we've got a product we can sell, and they're looking to sell it in the millions, maybe not at a high price, where if it comes over to the US first, it's going to be captive technology behind one of these consortium paywalls, and it will be at a high price. So what does the US do? Well, they buy into the technology and then just create alternatives of it and claim it as their own. Other countries ignore intellectual property rights, patents and copyrights and stuff. The US has a tendency of taking a patent and going, that's not really a patent. Everybody can do that. And it turns out only certain companies can do that. So as I was saying, indistinguishable from gobbledygook, and strangely enough, I misspelled gobbledygook. The gook part's right, but the gobbledy, I think, is misspelled. They didn't catch it, though. There are social media channels, and Sabine Hassenfelder is one of them, where they try and, with their education, take what they know, learn the new stuff, put it together, and create a baseline for the general public to maybe more easily assimilate this new knowledge that's coming out there. But if you're not into watching her stuff, because even if she's dispelling the gobbledygook, it's still sciencey stuff that not a lot of people have the desire or the understanding vocabulary to uptake that, to assimilate it, even through her attempts. But that's not, to put anybody down, because life, family, hardships, economic situation, your choice on what's important in life, there are things that are going to get away, and not everybody should be expected to know everything. That's just an incorrect presumption. So the general population has a foundation of knowledge that, as the educational systems sort of let us down, the gap between the new advancing stuff and the baseline that people know and understand is getting wider and wider. And that opens the opportunity for, like I said, people are going to try and be monopolistic for revenue opportunities. They're going to spin it their way. So, for example, quantum computers. I've done a lot of deep research into quantum computers and qubits and things like that. And there is a professor at a university down in Australia. If you want to watch a couple of hours worth of videos on it on YouTube, you can watch that. But that will explain to you not just that tank with the liquid nitrogen or liquid helium in it, but all the technical minutia, the little pipes and tubes and all the stuff that's in there. That's not the quantum computer. The quantum computer is something about the size of a playing card that sits at the bottom of that tank. Everything else is the infrastructure required by the quantum computer, including the stuff they don't show you, the giant racks of mechanical and electronic equipment to make that stuff work. You need that in order to make it work. And the whole issue of are qubits reliable or not, they found a simple solution: dump more qubits into it. And instead of having physical qubits, which could be unreliable, you create a bunch of physical qubits, and then you encode error correction data in the qubits. And now you have virtual qubits. So you may have a 12-to-1 relationship between physical qubits and the one virtual qubit that's now reliable. So you got to see how the big guys are spending money to ignore the man behind the curtain kind of thing. And the same thing is true of AI, artificial general intelligence. Is they're spending billions on it, but what can it actually do for you? And you even see TV commercials for like Alexa Plus. Apple would like to say they're involved in it, but they're putting out the chips, but they're quite a bit behind on the software. And someday there'll be like a Siri Plus, I guess. So there's a good movie from days gone by called Real Genius with the late great Val Kilmer in it. And they created a gigawatt laser. And another one of the team members said, okay, I'll create the beam alignment and focusing so it'll work from a satellite in orbit. Well, what good is a gigawatt laser in orbit? And one of the other science members of the team goes, it's for making giant Swiss cheese. And then the one that really gets it and understands, connected the dots, he said, it will allow you to vaporize a human target from space. And that was the real reason why they had the college students working on this advanced science, is not for some practical purpose in the real world. It was a clandestine military mission that unless you could connect the dots, you'd never see this plus this plus this equals that. There are increasing things that are supposed to prevent one organization from basically stripping down and reusing the works of another organization. We have this thing called the Digital Millennium Copyright Act that says you shouldn't reverse engineer stuff. But then there's all these YouTube videos on how to reverse engineer things. And then there's digital rights management. You can't record that video or that audio because it's encrypted, and the devices that would process it can't do it because they're conforming to the DRM. You can very easily create devices that will record it. It's just sampling digital data that don't obey DRM. Take it for what it's worth. These barriers aren't assured barriers. Stuff that initially starts out in black projects is going to wind up in the open. The technology that they demonstrate, people will just go, sure, but what is it good for? Somebody out there is connecting the dots, and it may not initially have a practical use, but maybe it's useful in creating something else that is useful. Maybe there's a military purpose that you don't really see until later on, like drones. Drones are now common in warfare in the Ukraine, apparently in the Middle East, elsewhere. Drone sales are going like gangbusters, and people are buying the drone parts and making their own drones. And a particular company in China, it's illegal to sell certain models of their drones in the US for personal use because it can be repurposed for military use. Being somebody that's worked with computer servers, I've watched storage, the direct storage that the computer uses, not the RAM for memory, but the immediate storage, like rotating media hard disk, magnetic storage. I've watched that grow up over the years. And when you've got a disk drive that's down to 3.5 inches, they tried making them 1 inch, and the physics was not great. They couldn't really shrink it any further. So they stopped at 3.5 inches, and they started improving the technology. They used to use magnetic fields to flip the bits in magnetic coatings on metal platters. Nowadays, to flip the bits, they actually use a laser at a 1 nanosecond pulse level to create a plasmon, and that's a whole concept unto itself in plasma physics. You're not able to actually fine focus a laser to 1 nanometer. But if you run it through a process, you can squeeze the light that comes out inside of a helium chamber, and you can take the metal crystals that you're now coating the plates, and you can actually flip the magnetic polarity in 1 nanosecond. So if you see that there's now 30 plus terabyte hard drives that are available for like $730, they go in servers. These are pretty awesome things. Think of it, 30 terabytes. If you go back 20 years, that's many times the total storage of the US Library of Congress on a drive that's 3.5 inches that costs $730. The next thing they're running up against is they can't transfer the data fast enough that if they put all the data on the drive, that they could back up the data off the drive in a reasonable time frame. They still have bottlenecks. But that may be like out there technology that not everybody's savvy of. But LEDs, you go buy a bright white LED on Amazon and you say, I need one like a floodlight for the area outside my garage to illuminate my driveway. I'll buy a 100-watt LED. And it's pretty cheap on Amazon. But then you find out the power supply, the constant current power supply to drive it is actually bigger than the LED element itself, and that it'll produce a lot of waste heat, and the dissipation of the waste heat is far larger than the LED itself. What are these used for? They're used for making street lights and for making like helicopter floodlights and searchlights. And so it's a practical technology for its intended purpose, but it's impractical for average people to use it. And people say, why do you need a 100-watt floodlight on your driveway? That's too bright. And they want communities to ban them. Well, what you don't know is that, oh, there are already 500-watt LEDs available. It's just like a step up. They put some more chips in it, and the same size LED, which is about 4 inches across, instead of being 100 watts, is 500 watts. And it's ultra bright white. It's 6,500 Kelvin, 9,000 lumens. That's for the 100-watter. There's all kinds of technologies in the products that we use nowadays that we no longer have the ability to diagnose what's gone wrong with them or to repair them. And we just use them and go, it's not working right anymore. How many people know that that new fiber optic router that you get into your house actually uses something called temporal solitons? It sounds like a science fiction term. Nope, it's a real thing. It allows improvements in fiber optic technology because they can better contain the wavelength spread within the fiber. Makes the fiber cheaper, and you can have more gigabits in the fiber. Or the specialized cores that they're putting in your laptop and your mobile phone, and their digital signal processors and large language model executors and AI engines, as well as, the graphics engines. This is technology you're currently holding in your hand, and if something goes wrong with it, you don't know what part's gone wrong. You couldn't repair it. It's all surface mount soldering. You know how to do that. So throw that phone away, buy another one. And now in the US Congress, they're having discussions about the concept of right to repair, where the companies that are making the products, in order to make it cheaper for them to make the products to integrate the higher technologies, they're making them not repairable. So they're making components that you don't buy a device and then you buy like add-on RAM for your laptop. You buy a laptop with 16 gig or 32 gig or 64 gig, and that's it. If you bought small and you need more, you throw away that laptop or see if you can sell it to someone, and then you buy a whole new laptop just to get more RAM. Now they're making specialized circuits that replace all of the interface components. So there's one either field programmable gate array or application specific integrated circuit that does all the stuff to talk to all the different interfaces. And if part of it doesn't work right or goes bad, replace it. It's easy enough to do if you're thinking about, well, I just throw out my toaster and get another toaster, or my blender, or my electric razor. There's computers in those things nowadays, but you couldn't tell it because they don't tell you that. They just show, hey, I've got a razor, and it's got a little display on it that says it's charged to 100%. It's not little lights like red, green, yellow. It's the digital display that says 100%, and it can change in increments of 1%. That means there's a computer in there. So if it suddenly starts making the display not correct or doesn't show up, your only choice is throw that one away, buy another one. I know of people that have had software configuration issues on their mobile phone, and they go back to the phone store, and the phone store says, yeah, it's not working right. You need to buy a new one. But they don't give you any assurance that the problem that you saw is actually going to be fixed in the newer model that you're buying. So what they do is they make you pay every month a certain amount of money. And after 2 years, that model's old, just come into the store and for no money, just pay that monthly fee every month. We'll give you a new phone. So that's how they solve problems. Even if your vehicle is not an electric vehicle, there's so much electronics in cars nowadays that you have no ability to diagnose it or repair it. It used to be that you could open the hood, do a little tinkering, maybe get some duct tape, or refill it with water instead of coolant, and you could get your vehicle limping along enough to get that vehicle back to the repair center where you could get a water pump replaced or something. Not anymore. If it's not working, call a tow truck. Used to be that you could work with websites and work around them, but now that everything is an app, if the app isn't doing what it needs to do or does something wrong or isn't working, you call customer service and they go, yeah, that seems to be a problem. We'll log it. There's no fix. There's no repair. Maybe when the new version of the app comes out, just download it and hope they didn't break something when they fix that. There's no assurance that using a new version or buying a new version of a product is going to solve anything. And it turns out that enhancements to products don't come from the customer base anymore. It used to be that customers would say, hey, I think you ought to do this. And companies would listen to them and come out with a new version and or tweak the software to get the improvement of the fix. That's not how it works anymore. It's done by a group called product marketing or product management. They look at, if we're going to do this, what's the gain on it? What's the return on the engineering investment to develop the software and then test it and document it? And if the gain isn't sufficient, it's a broke that's just not going to get fixed, or it's an enhancement that's not going to occur. So we're now on the side of, we just accept certain things. Do you know that your computer and your mobile phone know how to convert text to speech output? So it can actually receive text either from you typing it in or from another piece of software giving it text, and it will make the audio sounds such that it sounds like not just one person. It can be male, female, slight accents, different countries, different languages, and all of that is just matter of fact in your phone or your laptop. And also, it can now listen to you and convert what you say, regardless of your dialect and your language, and convert that into text that it can then use to decide what the computer is supposed to do or what you're supposed to go look up. That's just matter of fact technology nowadays. Computer and TV displays are so high resolution that we're now talking about pixel, the individual dots that make up a pixel. There is no longer a one-to-one between a pixel and one dot. There may be 64 dots that make up one pixel. You can't see the dots anymore. So if you lose 5% of the dots that make up the pixels on your display, you don't even notice it until you get up close and you go, there's a little tiny black spot right there. 3D animation software. You're playing a video game and it's lovely, smooth animation, and you don't worry about how many graphic processing units your mobile phone or your computer has. If it's got enough to make the video not herky-jerky, it's doing its thing. Mobile phones, cell towers, how they coordinate, which tower to use to talk to your phone, where you're located, how they ascertain your current location, how electronic maps work to provide you with directions, like where's the nearest, vegan restaurant to me where I am right now? How does it know that? Where does it get the data from? It's just taken for granted. Something as simple as, okay, you know somebody's phone number. You're on your mobile, you know their mobile number because they sent it to you in a text message because they know your mobile number. So you just click on the mobile number and it dials it. How does it know where? How does it know where the other mobile phone is? Well, the other mobile phone, when it connects to the network, it says, I'm here. And your phone, when you connect, it said, I'm here. And the network knows how to route from where you are right now to where the other phone is right now. How do quantum computers work? What's impractical? What's practical for them? There's a lot of stuff that's impractical and they cost a lot of money. How AI works underneath the covers, and what's the difference between just AI and GAI or AGI, the stuff that might drive vehicles or act as an agent that, as seen on Alexa Plus commercials. How do these robots do these human-like demonstrations and still not be practical? What is it that they just can't do yet? How does a vehicle drive itself more safely than humans do without LiDAR? These are things that just exist today. And if you don't comprehend them, that's okay. You're not expected to know everything. And the separation between what you use, the underlying technology, and whether or not you can understand it becomes wider and wider. And what you're using becomes more easily identified as it's just magic. If you accept it, you don't ignore it, that's okay. But if you don't accept it and you attempt to ignore it, you're actually in the minority. And if you take that dislike for the new stuff and you attempt to do things to regress that progression, there's a term called Luddite. If you're elected to a local community and you say, I'm going to make sure we don't have any of those bright white lights in our neighborhood. Okay, that's a thoughtful thing. You do realize that there are laws that say you can't put up that barrier. You can't stop progress. And you just have to live with it. So they'll be curmudgeonly not tolerant of it, but just like knowing they can't do anything about it. So I've talked a lot about advancements, and how about my prognostication? I'm future focused. Where's all this stuff going? A lot of it is going to be in the concept known as nanoscale metamaterials fabrication. This is where we're working at the billionths of a meter scale of individual features of devices, and we can now use physics and in specific cases optics at that scale, and that allows us to do things that we couldn't do otherwise, like nanoscale dots that make up the pixels of your TVs, nanoscale LEDs that when you put them together, you can control the color of them and make lighting strips that go in cars and such. How they can improve the performance of fiber optic trunks using nonlinear optics, and these material analysis combs that they create. Power management. Notice that power supplies are getting smaller and smaller and smaller. That's because the physics of the semiconductors are now reaching what is known as the ultra-wide band gap, or ultra-wide band gap, using material called gallium nitride, which allows it to more precisely and rapidly switch power. So the thing that is your power supply actually, instead of using a big transformer, just chops away at that high voltage until it ekes out the low voltage that it needs. We're starting to move things with radiation reflection pressure, initially in microscopes, X-ray microscopes, but we're starting to find out that that could be usable at a larger scale. Battery technologies, the anodes and cathodes of batteries, and how solid state batteries are going to be longer life. They can hold more capacity. They can charge faster. Once that technology flips into electric vehicles, I don't know, when you can do 600 miles on a single charge and you can charge up your vehicle to 80% in 5 minutes, and the batteries will last you 10 plus years. That's so much better than an internal combustion engine. That what do you complain about next? AI, once it becomes autonomous and you have agents doing things for you, things are going to get smarter. Things are going to be just moving along on their own, and you'll find that it's acceptable. If anybody's been to downtown Miami, there's this thing called the Miami Metro Mover. You might notice that there's no train drivers. There's nobody steering it. There's nobody, starting and stopping it, opening, closing doors. They're autonomous, and they've been doing that for a number of years. Aircraft. No, you can't make autonomous aircraft. Well, in China, there's a company called EHang that makes an EH216S that is already acting as a taxi in downtown urban areas to take you from the city center to the airport. What about marine vessels? Having a large number of crew on board a ship that's going to be sailing for months out at sea, that's expensive. If we could have the ship sail itself and use radar to know whether something's approaching, and then, maybe wake up the captain and say, hey, there's something 4 miles away and you probably want to take some action about it. But in the meantime, I'm just going to sail on to our destination and I'll monitor the ocean currents and the winds and the rain, and I'll keep the ship on course. There's already a commercial offering from a company called Saab. They used to make cars. It's called Autonomous Ocean Core, and you can retrofit an existing ship to make it autonomously go from port to port, saving a lot of money, which makes the labor cost less, which makes the cost of the things that are being carried less. Once robotics gets to the point where you can have a labor servant for you, it'll start out for those people that need it and for those people that can afford it. But eventually, why do I need to pay to have a driver drive my package from a Amazon warehouse 5 minutes from my house to my house, have the robot get in the delivery truck and drive it to my house, drop it off at my front door, and then send me the text message saying it's there. The self-driving vehicle becomes a self-delivery vehicle. And of course, the military will get involved and will now have warriors in the field that's going to change things. So as this separation, as this bleeding edge splintering is occurring, the number of people that know this minutia is shrinking as a percentage of the total population. It's already a small fraction of 1%, and it's going to get even smaller. And you'll have pockets, you'll have islands of subject matter experts for certain technologies that understand it, know how to build it, know how to maintain it, replicate it, enhance it, and they'll be pocketed. And let's say something happened, as in a particular island off of China, where it's most of the semiconductors on the planet come from there. If something happens and those fabrication centers go away, how does that impact the rest of the planet? Or, for example, an oil terminal in the Middle East accidentally goes boom. What does that do for the rest of the planet? Well, we've got to learn how to build its replacement quickly. If you pick a particular thing, like, let's say, integrated circuit fabrication, you may be seeing the last mobile phone new model that you're going to see for 10 plus years if you're lucky. The best way to defend against this is we need to start replicating those subject matter expert clicks areas, and they need security and protection. So what we need is a lot of small Manhattan projects. The fact that until we do something like that, we have this exposure, and if we have disasters of either the natural or the unnatural kind, these advancements are very fragile, and you don't want to go back to the stone knives and bearskins anytime soon. Why would we ever think it's going to go away? Because it has gone away in the past. The Library of Alexandria in Egypt back in the day, sure, it was destroyed by a mob, but that mob had political leaders, religious leaders. They were stoking their actions, and it only has been recent that we've realized the total impact to our society as a whole on the planet as to the loss of the Library of Alexandria. This was something as an astronomer I learned. When the Incas were conquered, they had all sorts of texts regarding positions and orbits of things in the night sky. And when they were conquered, one of the first orders that went out is destroy all that heresy. A lot of science was lost when the Incas' documentation was destroyed. Defacement of what's even written in stone takes away things. I remember recalling that in the different dynasties of Egypt, when one dynasty would go out and another one would come in, they want to scrape the other one off the wall. The so let it be written, so let it be done. Well, if I scrape it off, it's never been written, right? No, it's just not there, but it's also written over here. So redundancy. And I remember that during World War II, there were some soldiers that took a bazooka to the nose of the Sphinx. That's defacing. And then when power changes occur in the Middle East, there are people that rob museums. There are people that destroy entire cities worth of pre-culture. And then there are the intended efforts that are monopolistic. I don't know if anybody's into U.S. history, but we used to have a lot more public streetcars, and corporations came in and said, if we can make everybody want to own their own vehicle, they'll also want to have their own fuel for it, and they'll have their own tires for it. And instead of cheap public transportation, we can create an industry. So they found a way to make the majority of streetcars go away. One of the first EVs was the General Motors EV1, mass production EVs, and you couldn't buy them. You could only lease them. So when GM decided this isn't working out for us, we'll define them as a danger and we'll take them off the road, and you have no choice in the matter because you didn't buy it from us, you only leased it. And sometimes it's just the documentation. Prior to Hewlett Packard acquiring Compaq, I was a big user of Compaq computers because I could always go to their website and get documentation on how to install new circuit boards, replace things, repair things. And when Compaq was acquired by HP, the public support website was removed from the internet. If you owned a piece of Compaq equipment, that was your end of life signal. If you want a deep rabbit hole, you can Google Tartaria or Tartaria. You'll find out that there were indications that there was much more significant advanced, at least architectural capabilities and physics in the late 1800s than there were in the early to mid 1900s. If you remember what went on with Tesla, the guy, not the company, he was trying to create a solution for broadcast power where they'll figure out later how much you're going to pay every month for your power. There was no meters, so they couldn't tell how much you were using. You were just using. That's not good for revenue. So that had to go. There was a lot of things that if you get into Tartaria, you'll find out that they would be large public scale solutions that weren't meterable at the individual consumption level. That had to go. If you just remove something, that's one thing. But if you find it when you dig it up and then you cover it back over, or you find it and you brick it up so you can't see it anymore, that's deliberate, intentional to change the paradigm, to make something that's revenue based. And nowadays we can even do it with huge amounts of money in politics, and anything that isn't what you want it to be, we'll just toss that aside and call it conspiracy. Products will become obsolete, not usable anymore. So you need protections for the progression. The one that I like is something called the Internet Wayback Machine. If there's something on a website and you go, where did it go? You can go to the Internet Wayback Machine and look it up, and they might have a copy of it that's literally just read from where it was, saved, and now that it's gone from the original source, you can read it on the Wayback Machine. So in summary, the baseline education is shrinking as the technology is broadening. Not everybody can know everything. Disciplines are branching out into niches with very few subject matter experts, little clusters. The general population is oblivious to their reliance upon these things that they have no awareness of, understanding of them, and no ability to repair them. Solutions that come out aren't always better, cheaper, faster. Sometimes they create them so that they can create revenue. They can make you pay something for something that you wouldn't otherwise have to pay for. A monthly fee for streaming versus just going and looking at a website. Sometimes the technology in software can require advancements in hardware. People that wanted to upgrade their older laptop to Windows 11, there was this thing like, what's a TPM chip? And why does it need to be 2.0? That's so that the things that your computer is doing can be encrypted and tagged by which instance computer is using it. And that was to the advantage of, well, if I can tell which computer is using it and I can charge them a fee, I can associate that with the bill pay for it. So tagging. And as more separations occur, as more things become indistinguishable from magic, like agents associated with artificial general intelligence, they'll be indistinguishable from magic. We'll just find them useful and accept them and never understand what's underneath the covers. And there's a term from Babylon 5, if you were into that series, called Technomages. It's essentially kind of, think of it like wizards that understand technology and the people that keep up with it. It's kind of a lifelong commitment to chasing as things change and new stuff comes into being. I could probably be identified as a technomage for how much effort I put into to chase the new stuff. But even that's kind of a lifelong endeavor. And you're going to have small groups that just know how to create what they're working on, but don't know the rest of it. And then you're going to have the people that know just enough to milk the people that don't know anything, and you'll have technological charlatans. If you want to know the difference in wizards, should say Morgana. Think of Morgana versus Merlin. Merlin was sometimes nasty, but tried to be benevolent and help the general population out, whereas Morgana really wanted to make use of them. And there is this thing that requires real protection called technological fragility. Is it hopeless as things get broader and people know less? No, I'm in favor of progression. I want to keep that going. I don't want to put a mark in the ground and go, we'll stop here. No, that doesn't make sense. But I remember from the movie The Kingsman, what Galahad said is, I sometimes envy the blissful ignorance of those less well versed in their stuff. So yeah, I'm sometimes, when I think of how much I just had to put into learning something, it must be nice to not have to think about such things. And then lots of links as usual. And if you didn't know what a soliton is, there's two kinds. There's spatial and temporal. We currently have a keen handle on spatial, but not temporal. But if we could just get temporal solitons working, huge revenue potential in optics. In other words, you wouldn't need lenses anymore. You could just electronically focus things. And then if you want to know about those fancy new disk drives that use lasers to heat magnetic crystals. And if you weren't aware of the concerted effort to get rid of public streetcar systems as General Motors did, and then the EV one, if you weren't aware of that one. And if you want the very deep rabbit hole, there's Tartaria. And then the Wayback Machine. It's actually at archive.org. Okay, comments, question. So is there any technology in your day-to-day life that just works for you? You don't have to think about it. But when you think about it, it's like, I don't know how it does that. It just does it.
Well, yeah, plenty. I mean, just the phone I'm holding in my hand.
Yes.
Most of that is magic.
Yeah, and not just the phone itself, it's all the stuff that's in the phone. It's not just the cellular mobile communications and how all that stuff works. It's the numbering for routing, the text messaging. There's multiple protocols for text messaging, and different mobile service operators use different protocols to communicate to one another as gateways, and how those things can work in fractions of a second. And yeah, and that's just in your mobile phone. And then you go over to your laptop and there's a whole nother thing there. There's Bluetooth and Wi-Fi and different bands of Wi-Fi, and like,
yeah, hardware, software, and infrastructure. It's all amazing.
And they do have an interplay with one another.
Yes.
Wi-Fi, for example, the 802.11b IEEE standard for the original 2.4 gigahertz Wi-Fi, they realized that they were going to be at the 2.4 gigahertz range and spreading over, including an area that is where if you put out this particular frequency wavelength, it will excite water molecules. Oh, that's microwave ovens. So the early Wi-Fi actually had to be aware that if somebody turned on the microwave oven too close to your Wi-Fi transmitter or receiver, you had to like notch that out, notch that portion out. Why didn't they just start at like 2.5 gigahertz? To quote the original Oh God movie, where were you when I needed you? because since then they've gone from 2.4 gigahertz to 5 gigahertz to 7 gigahertz, back down to 6 gigahertz, just looking for notches where they can have faster and faster. All of that minutia plays together. And then on top of that, radio astronomy, those scientific people that do radio astronomy, there are bands where they have to share because there's already technology out there that's polluting that particular band, that particular range of frequencies. And so go put your giant radio antenna inside of a mountain range so that the stuff is not available anymore. It won't go over the line of sight over the mountain. And then they put radar in cars to make sure you don't run into things. And the particular radar in the cars, oh, they infringe upon that band. Green Bank, the big radio antenna at Green Bank, if it's and pointed in a certain direction too low to the horizon, there's a highway that comes off of the mountain edge, and all the cars that now have collision avoidance radar are transmitting. It's 100 milliwatts. It's no big deal to the giant ear listening for deep space in that band. That is like an overpowering radio frequency. And they went back to the US agency that manages the radar they put in cars. And they said, no, we're not going to take that out of the cars. That's very valuable. It saves lives and doesn't cost that much. And the car maker said, no. We like how much it costs because it's just enough where we can charge you more for it in the car, whether it saves your life or not. So it kind of like inches up the price of a car. And the radio astronomers were told basically, live with it. So they had to put up a fence so that when the cars turned in that direction, that there was a Faraday shield to prevent that wavelength from hitting the big dish.
Wow.
So, yeah, these little minutia things that only little, clicks of subject matter experts go, that's a problem. How do we deal with that problem? Well, you go back to the source of the problem. Now they're not going to do anything about it. You got to create your own solutions. But it's all within these little confined segments of the population that life goes on for the rest of us, and we don't have to deal with that minutia. Okay. Anything else before I stop recording? Hearing nothing.